Hello, everybody. Welcome to a new episode of AZ Security. My name is Dinan Paardenkoper, and I'm a cloud architect at IT Impressive. And today we're going to talk about GitHub Advanced Security. And with me today, I have a special guest, and that is Joylynn. Can you please introduce yourself, Joylynn?
Yes, hi everyone. My name is Joylynn Kirui. I'm a senior cloud security advocate at Microsoft, and I'll share my handle as well. I do everything developer security, and I'm really looking forward to the discussion.
Cool, amazing. Um, for the audience that just joined in, GitHub Advanced Security, what do you have to think about? What is it? Can you explain, maybe?
Okay. I don't know if maybe I can direct also to my slides so that you
Yeah.
can.
Yeah, of course.
Is it visible?
Yes, it is.
Oh,
Thank you.
okay. Perfect. So maybe just to start off, before getting into the intro of GitHub Advanced Security, I just want us to see the overview of the current state of AppSec and why we need GitHub Advanced Security. And then now we'll get into a little bit of practical as well in terms of demos of how easy it is to actually deploy and secure your workloads as well using GitHub Advanced Security.
Okay.
So yes. So you've probably seen this before, Dinant. So security is an issue for all of us, that's for sure. So unfortunately, statistics actually show that many security issues start at the application layer because you see the application layer is where most of us actually interact with all these solutions. So we have a lot of investments that have been done in the security scanning tools, but applications still remain insecure. So traditional application security methods have failed organizations in many ways, with actually 85% of applications still containing known vulnerabilities, and little change in this posture has been shown in the last 10 years. So there's a lot that we still need to do around this. You probably remember the Log4j vulnerability a few years back, right?
Yeah, how can we forget? That was a
We
big
can't
impact.
forget that. We can't forget.
Yeah.
We had sleepless nights at that time. Yes, so actually that one impacted more than that 5,000 different Java artifacts. So the vulnerability, which actually comes from a popular logging tool in the biggest Java library, allowed an attacker to perform remote code execution by exploiting insecure feature, which was exposed in the logging library log4j. So you can imagine there's so many aspects or very many vectors that can be used to attack your applications. So another example that I think you also remember quite vividly is the SolarWinds attack. Uh,
Yeah, that's also a big impact in the world. Yeah.
yes, so you can imagine now for that one as well. So an attacker infiltrated their software supply chain and modified the platform updates of the SolarWinds plugin. So you can see there's a lot of vectors that can be used to compromise. So so that's why it's important just to highlight this. So we find that there are three main pain points. So developers and security teams have remained siloed. So most developers are not empowered with security knowledge in their everyday work. So as long as a developer is not empowered in secure coding, they will always be developing insecure products. And by the end of it, like by the time it gets to production, like we have a lot of security vulnerabilities which can be exploited. And also with the transition to cloud native environments, customers are also shipping more frequently than ever. And security teams are actually struggling to keep up with the pace of development and to optimize security at this shipping frequency. So resulting in a lot of security technical debt. So by the time you're shipping as often as possible, so we are seeing a lot more being pushed, which have not been reviewed thoroughly. So a lot more security vulnerabilities found in production as well. And then we also see like we have a lot of modern code bases. So many organizations rely on multiple fragmented tools to provide scanning coverage. So I've heard this from so many people like, yes, we're using this solution, we're using this tool for scanning, we're using this tool for scanning. And at the end of the day, it provides you with a lot of scanning results, which might be a lot of noise as well. So, but yes, you have the good intent of maybe scanning all your resources, your workloads. But if you are incorporating a lot of tools as well, like we have a lot of false positives and as well as false negatives. So at the end of the day, you have to do a lot of analysis. So it's very important just to have thorough POC on whatever scanning solutions that you're going to embed within your environment.
I agree. It's sometimes hard to, if you have a lot of tools that are overlapping each other, it can be a big plus, but it's mostly a big pain because you can, they have to work together, and that's mostly the biggest problem, right?
Yes. So I remember the time like when you were starting off with all these, especially like the DevSecOps initiatives. So even in the IDE, I was working with some developers and we had deployed a scanning tool to find the security vulnerabilities from the IDE. And I remember one developer complaining to me and saying they've actually spent 2 days reviewing all those results that came from this security tool, and it took him like around 5 hours to write what he was actually reviewing. So he ended up spending a lot more time on reviewing rather than on what he built. And it turned out that those 2 days that he was spending was actually on false positives. So it was actually giving him a lot of noise. So that's why it's very important to do thorough analysis around what you're actually adopting within your organization.
You mentioned DevSecOps. Is
Yes.
that a methodology which is being adopted by many companies? Are you seeing that it's still a divided world, DevOps and security, or is it just nowadays DevSecOps?
Oh yeah, so as I mentioned earlier, one of the key challenges that we're still seeing is developers and security team have remained siloed. So
Okay.
this is still an issue. So we are not yet there. I've seen very many clients, very many customers as well, who have adopted the DevSecOps initiative properly, but very many of them as well are still not doing it correctly. So the developers are still working on their own features, their own products, and then by the time it's getting to the security teams, like they were not incorporated from the word go. So the
Mhm.
whole aspect of DevSecOps is whereby we are integrating security scanning throughout the software development lifecycle. So this includes from design. So by the time you are having the whole concept of the solution. By the time you are drawing the whole architecture, you're putting the security requirements from that time as well, and all the way until the solution is running, it's in production. Because remember, once the solution is or a product is in production, what is secure today is not secure tomorrow because we have all these 0-day vulnerabilities. So we always have to scan for security vulnerabilities every so often and make sure that we are updating
I agree. It's changing that fast. I mean,
very
all the
fast.
bad guys out there are not sitting still as well. But
Yeah.
I'm seeing a known picture, shift left approach.
Yes. So the reason why I like showing this is, you see, it's giving us an overall view of that software development lifecycle from the time you're developing or in design, and then you're developing, you're building, and then you're testing, and then you're in production. And then if a breach happens when it's in production, you can see it's a lot more costly to fix those security vulnerabilities. So it's to our own good if we fix all these security vulnerabilities in as early as possible in the development stage, because at the end of it now we'll have very less technical security technical debt and exposure as well. So this is what we call shifting security left, whereby we are incorporating these security checks as early on as possible, from the design or development, or before actually getting it to production.
I agree. It always helps also with the integration with the security team. You can better inform them at the earlier stage. We can then fix the things easier instead of just repairing everything behind the scenes afterwards, which
Yes,
even costs more, mostly more.
yes. So I think maybe you are probably now wondering, okay, so what is GitHub Advanced Security? Um, so this just shows the capabilities that are available for GitHub Advanced Security. So this is an application security solution that empowers developers. So advanced security is embedded right into your workflow to help prevent vulnerabilities and credential leaks without slowing development. Because I know what we are keen on, especially in the DevOps, is deploying as many features as fast as possible. So with incorporating advanced security, you are deploying as fast as possible, but still getting the security vulnerabilities as early on as possible. So GitHub Advanced Security is like having your own personal security consultant review every line of code with insights from security experts from around the world. So that's what I like about GitHub Advanced Security, because you have a whole community that's behind you, and then now you're leveraging all that. So it's like you have a personal consultant to review every line of code.
Nice.
Yeah. So these are the core attributes of the solution. So we have the secure supply chain, so where we have unchecked dependencies. So you find that 80 to 90% of code bases is actually made of dependencies. So typically open source services as well. So you can imagine, so if you have any dependencies that are vulnerable, you are introducing 80 to 90% of vulnerabilities into your code base. So we only work on around 20 to 10% of the code base. So the rest are like third-party dependencies or open source components as well. So we really need to ensure that what we consume is secure and safe.
Can
And
you
then,
also
yeah.
can you also use a sort of patch mechanism if for 0-day exploits? Does that also being available in GitHub Advanced Security?
Oh yes, I'll touch on that as well. So the thing I like about GitHub Advanced Security is also always keep scanning, and then it will also create PR for you whenever there's a security vulnerability that can be fixed using like maybe by just updating a particular package. So it creates a PR for you automatically, and then all you have to do is just go in, review it, and accept it or merge that PR. So I'll touch a little bit on that as well in the demo.
Cool.
So the other capabilities include like securing the code that you develop. So this ensures that it is free of vulnerabilities, and it also ensures that there are no secrets embedded in your repository that someone can use to access your critical infrastructure. Because I've seen this so many times. I've seen even in this era of AI, I've seen so many people putting like their Azure OpenAI API keys directly in their code base and then now exposing it on GitHub. So you can imagine what kind of damage can happen because you've actually leaked access to your critical infrastructure.
Yeah, I think that GitHub can also prohibit it
Oh yes, oh
to your
yes.
code
I'll also
repository, right? I mean,
yes,
it's a sort
yes,
of
yes.
securing the developer for oops moments, so to speak.
Oh yes, you really need to protect yourself from those oops moments. So I'll also show you as well in the demo on how to prevent that from actually happening. And then the other feature as well is integrating into every aspect of the development lifecycle. So whereby you can connect to all your GitHub events, your push, pull, your PR, your merge, and all those aspects as well. And then you can also run the different scans at different times. So you can have focus scans during the developer PRs as well, and deeper scans nightly for security to review or try it as well. So then you also have your platform for security governance. So where you have less than 1% of companies that scan their code and more than 260 times a year. So it's very important to always be scanning as often as possible. So the security governance platforms allow security teams to define acceptable behaviors of the repo and to also enforce this on every push or PR merge. So this, all these are the capabilities that are available in GitHub Advanced Security. And also some of these capabilities are available for free in public repositories. So the reason I like highlighting this is so that you can go in and try it yourself. So for public repositories, you can be able to do code scanning and check for the code that you've actually written yourself. Is it vulnerable? And then we also have secret scanning. We have all these capabilities that are available for public repositories. And if you are working on a private repository, you need an advanced security license. so it can be able to scan all this. But yes, so at least since you have a public repository, you can be able to go in and just see the whole capabilities that are available using GitHub Advanced Security.
Yeah, I can imagine. But for bigger companies, the private repositories will be de facto standard, I guess.
Oh yes, it has to. Yeah, definitely, it has to be. So, so let me just summarize GitHub Advanced Security into 3 areas. So these are the areas that we usually talk about. So supply chain. So I've said that 80 to 90% of your code base is borrowed code, or what you call like open source components, third-party components. So the solution that's under GitHub Advanced Security is called Dependabot. So Dependabot is an automated dependency management tool. So it's responsible for keeping project dependencies up to date. So it regularly checks for updates to libraries and frameworks used in a project and automatically opens pull requests to update dependencies to their latest secure versions. So Dependabot contributes to maintaining a secure and stable development environment by addressing vulnerabilities present in outdated dependencies. So I think we've all heard of supply chain security. So what Dependabot does is just to make sure that whatever dependencies that we're using, they're up to date to avoid all these zero-day vulnerabilities. And then also, if there's a zero-day vulnerability, so Dependabot will also be scanning every so often, and then it will give you an email alert or however you've configured it, saying that your this particular line of code is now, or this particular dependency is now vulnerable to this particular security vulnerability. So I think you probably know how we issue the rating, or so normally with zero-day vulnerabilities, there's a CVE ID that's assigned to a new security alert or new security vulnerability. So even with Dependabot, it will tell you that for this particular issue, this is the CVE that is assigned to this particular security vulnerability.
Nice
So
integration. Yeah.
yes, I think I can show you in action, right? So that you can appreciate it better. Yes. So with Dependabot, there are a couple of ways like you can be able to see how to do this. Let me do this. Okay, so when you're in your repository level, you can be able to enable this within the repository level or on the organization level as well. But I'll show you how to do this in your repository level. So all you have to do is to go to your settings, and then you scroll down to Advanced Security. And then you'll see all the security capabilities. So you'll see that you have Dependency Graph. So Dependency Graph will give you an overview of all your dependencies. So as I said, like we have so many dependencies. So this will give you like, so you have all this list of dependencies and dependents as well. And so it's very important. All you have to do is just to go in and enable that. And I've mentioned about Dependabot. So Dependabot actually keeps your dependencies secure and up to date. So for now, mine is paused, but all you have to do as well is just to enable that. So, and then we also have Dependabot alerts. All you have to do as well is to enable that. So Dependabot alerts, as you can see here, it receives alert for vulnerabilities that affect your dependencies and manually generate Dependabot pull requests to resolve these vulnerabilities. So you can imagine if you have a zero-day vulnerability tomorrow. So what Dependabot alert has done is it has found this dependency is vulnerable, so it will create a pull request for you. So all you have to do is to go in and to review that pull request and to accept it or not. I'll show you as well. And then the other one is Dependabot security updates. So this one, it automatically attempts to open pull request to resolve every open Dependabot alert with an available patch. So this one opens a pull request to resolve those vulnerabilities. This one also tries to resolve every open Dependabot alert with an available patch that's available. And then we also have group security updates. So you'll probably find that one pull request would be resolved So you probably have like 5 dependency issues in one PR. So this one sort of groups all of them, and then you are able to fix all those security alerts using one pull request. So it's easy for you as well to review with less noise.
Exactly.
And
Less noise and not a sea of MR requests, right?
exactly. And then we also have the Dependabot version update. So this one allows the Dependabot to open pull requests automatically to keep your dependencies up to date when new versions are available. So this one is very important because, as I said, just to prevent these zero-day vulnerabilities, at least GitHub has all these security researchers. So you're always, you see, as I said earlier, it's like you have your own personal security consultant. Yes, so you can see all these Dependabot features that are available. So let me just go here to one of the pull requests that has been created for us. So you can see here, this is how it looks like. So it tells me I need to bump this particular dependency from this version to this version. And then it gives me an update on why that is very important.
Okay.
So let's see this. So it will say Dependabot will resolve any conflicts with this PR as long as you don't alter it yourself. So all you have to do, so it goes through a couple of checks to see if there's anything that will break. And then all you have to do as well is just to merge it and accept that. Let's see another one, another pull request. Let's see if we have any critical ones. Okay, let's see this one. So you can see for this one as well, because for all our dependencies usually have like the version number. So at least it will give you the vulnerable version and the version that has that issue fixed. And then now all you have to do as well is to go in and review and then merge that pull request.
Nice.
Okay, it's as simple as that. It's amazing. Yes,
exactly.
so since
Yeah,
we're talking
it's
about
very helpful.
dependencies, so we have this dashboard as well, which shows you all the security vulnerabilities. So for dependencies, you can be able to see all those dependencies that are out of date. So in this case, you can be able to see that, so it's ordered in order of security severity. So we have like from high, critical, okay, moderate, and all that. So if you go to one of them, so remember what I said again, we have the CVE. So a CVE is assigned to a particular security vulnerability or zero-day vulnerability. So if something is found today, so it will be given like CVE 2025 and then a unique ID to show that it's a particular security vulnerability. So that's how you can be able to identify for that one. And then it also gives you the overall view in terms of metrics, the severity of that security vulnerability. So it gives you an overview of explanation of that dependency security vulnerability as well, and how to go in and fix it. So in this case, it shows that these are the vulnerable versions and how to actually go in and fix that. It's amazing, right? It's very simple.
Definitely. How is GitLab getting this information? Is that just a public source which GitHub is using? Or is it its own database where the CVEs are coming from, the information at least?
So GitHub has also its own security databases. So we have security researchers as well who are always working on that and then updating. But remember as well, I think you should check out like ExploitDB, or we have several databases for new security vulnerabilities. So it always has to be updated. So GitHub is always on the lookout on all the security vulnerabilities, and then now they update that within the database. So you can be able to just go in and scan against what they have in the database.
Okay.
Yes.
Cool. Nice demo.
Yes, so I think we can just go in and see the other capabilities that are available, because we have a lot to show. So apart from dependabot, we also have secret scanning. So um, so for secret scanning, it's actually a very critical security feature within GitHub Advanced Security. So it's designed to identify and mitigate the exposure of sensitive information, such as API keys and tokens within your code, source code. So this scanning process is essential for preventing unauthorized access and safeguarding confidential data. So secret scanning operates by searching for predefined patterns and signatures indicative of sensitive information. So because you've seen that there's usually a way that you can identify maybe an organization's secret. So in this way, like you can use like a regex to go through every line of code to know that probably this particular token belongs to maybe Azure. This particular token probably belongs to Slack. So it's always going in and scanning for that. Let me show you how we actually do this scanning process. So when a secret with a known pattern is committed into like a private or public repository in your project, secret scanning sends a notification to all repository administrators about the commit that contains the secret. So how secret scanning lifecycle is on a public repository works. So this diagram just summarizes the secret scanning process for public repositories with any matches sent to a service providers to verify their endpoint. So GitHub maintains these different sets of default secret scanning patterns. So we have the partner patterns. So GitHub currently scans public repositories and public NPM packages for secrets issued by specific service providers because these are known patterns. And then we also have user alert patterns. So these are used to detect potential secrets in public repositories with secret scanning alerts for users enabled. And then we also have push protection patterns. So this is used to detect potential secrets in repositories with secret scanning as a push protection enabled. So this prevents you from actually merging any of these secrets in the first place. Because remember, by the time your secret is already on GitHub, that is as good as compromised. So the
Definitely.
best
Yeah.
way, so you have to revoke it. So that's why you can see here, if it's actually found and it's verified, the first thing that you need to do is to revoke that secret. And I
Yeah.
know it's a pain, it's a real pain even to rotate keys to revoke. Now it's a whole process. So you'd rather just be safe and prevent this from happening in the first place.
I totally agree. I think that is one of the biggest issues in the past that people just pushing everything, and they still have to think like some things you don't want to send over. Yeah, totally agree.
Yes. So let me just show you real quick how to do this.
Yeah, please.
So I'll show you again on the repository level, still under security, under advanced security.
Right.
So we've already covered the dependabot bits. So you just scroll down all the way to secret protection. So you need to make sure that secret protection is enabled. So we have all these checks. So this validity checks, it actually verifies that the secret is valid. So by sending it to the relevant partner. So the partner verifies that if it's actually true that it's a secret that's actually in use or not. And then we also have non-provider patterns. So it also scans for non-provider patterns. Because remember, in some cases, that you can create your own patterns. So it also scans for those patterns. And then it also scans for generic passwords. So this one, Copilot secret scanning, it detects passwords using AI. So you were using AI as well to advance and find all the security issues as fast as possible. And then the other one that we've just mentioned is push protection. So all you need to do is make sure that push protection is enabled. So this push protection will block commits that contain supported secrets.
And there he is. Yeah,
Okay.
exactly.
Yes. So in some cases now where you're using like you have your own custom patterns, You can create your new pattern, and then you define that pattern name, and then you give it, so in this case, I can have it like my custom secret, and then this is the regex that I'm checking for. And then I can test it against each, so it scans through every line of code to see if there's anything with this format that fits this. And then it will tell me which secret is actually available there. So
One
it's
question.
amazing. Yeah.
If I have maybe I use different kind of languages, Java, Go, or Ruby, does it matter in which language it's being written, or it's just anomalous? It's just reading through every kind of code. It doesn't matter.
So, so I'll show you as well on the code scanning bit which languages are supported. But
Okay.
when it comes to the secret, remember there's that particular pattern that you use for the secrets.
Hmm.
So this secret is not really like agnostic to a particular language. So it's
I
just
agree.
probably like a regex, a regular expression of how you are representing your secret. So yes, so as long as your secret is defined, so it just scrolls through every line of code for that particular regular expression.
Right. Okay.
Yes. So let me show you as well how it looks like. So we have remember this is a dashboard. So we have secret scanning, and then in this case we found several. So in this one we have one, and then it tells me which line of code. So it tells me that on line 25 of this particular file, I have this particular basic authentication that's hard coded. So I need to go in and first of all, definitely revoke that and um, use secure authentication methods as well. So remember that bit of push protection. So let me just show you. So I have a file that has some secrets embedded. And let me just try and upload that.
Okay, so just to get a clear understanding, what you just shown us is something which is already too late because it's in GitHub being saved in the repository. And now you're going to show us like, what if I'm trying to upload a file which is not known to GitHub yet, right?
Exactly. Exactly.
Okay, cool.
Yes. Okay. So for this one, let me move this first and upload that file because it will show my file directories. I don't want you to see all my files.
No, that's no problem.
Okay. So I have this Python file that has some secrets embedded to it. So I want to commit directly to the main branch. Let's see what happens, because remember I had push protection enabled. So you can see it will actually block me from uploading that file in the first place. So it not only works for files, but also if you are on Visual Studio Code, you're trying to push your code and merge it to your repo on GitHub, it will prevent you from actually merging your code because it has found a secret. So then it will tell you
Yes,
that you
yeah.
need to be able to fix that.
And in this case, it is something about Slack, right? I mean,
Yes,
it's also
yes,
saying like which code he detected.
yes, because remember, we're using patterns. So Slack has a particular secret pattern. So it detected and it went through and said, okay, so this one is the pattern that's used by Slack. So you need to be able to go in and revoke this. So in some cases, it might be a false positive. You want to fix it probably later because it's probably like a testing environment or you're using it for test. And then so you can be able to mark it as a false positive, and then now you can continue. Otherwise, if you don't do that, you have to go in and fix that. It won't accept you to merge it at all.
It's nice that you're getting some options as well. I mean,
Yes.
I like the idea like I'll going to fix it later if you are in a sort of demo environment. But it's great that you have some options and at least seeing the danger, and then it's up to the person who is at behind the scenes, right?
Exactly, exactly. Okay, so I think we can go to the next feature that's available. So the next one is around code scanning. So I like what you were asking earlier around the languages that are being supported. So this is where we're going to touch on that. So for code scanning, so we use a tool in GitHub Advanced Security called CodeQL. So CodeQL is the analysis engine used by developers to automate security checks and by security researchers to perform variant analysis as well. So using CodeQL actions with GitHub Actions workflows allows you to find vulnerabilities before they are merged into the code base and integrate the results directly into the developer workflow. So you can configure the repo so that merging is blocked when critical vulnerabilities are not yet fixed. So even in the whole DevSecOps pipeline, you can be able to onboard like GitHub Advanced Security, and then if you find any code security issues, it prevents that merge from actually being successful until you're able to fix those security vulnerabilities.
Okay.
So in some cases, so for running queries against a CodeQL database, so there is a community-powered GitHub query set, or that you can be able to use, or you can create your own custom queries as well. But the simplest way to use it as well is on GitHub itself. I'll show you as well how to do that real quick.
I see a SAST, so it is static. Is
Yes,
CodeQL also being available in a dynamic form?
not really,
Do you
no.
know?
No,
Okay.
it's not. So as
Okay.
of now, it's only available like you can be only on SAST as a SAST tool. So I like that you brought in the aspect of SAST. So before I mentioned about Dependabot. So Dependabot is an SCA tool. So that's a software composition analysis tool. So when you're
Mhm.
talking about the dependencies, so that's when we talk about SCA. And then now when you're talking about static application security testing, so that's where we're talking about CodeQL. So static application security testing is going through every line of code to look for security vulnerabilities. So this also entails like the OWASP top 10 security vulnerabilities, something like SQL injection. SQL injection will be found through the code security vulnerabilities. So it will tell you probably this line of code you need to use parameterized queries. So it will tell you how to actually fix that security vulnerability. So let me just go in real quick and show you how to enable this. Just the same way on the repo level. But remember, you can still do this on the organization level, so that because in your organization level, you have like probably like 1,000 repositories. So you can be able to know within all these thousands of repositories, how many of them have these security vulnerabilities. So by that, you probably see that there's one security vulnerability that's quite prevalent against all of them. So that would show you that you probably need to do like security training for your developers, because it's something that keeps recurring every so often. Yeah.
I
So
would yeah, recommend that. Otherwise, they're a little bit lost, maybe in all the
oh yes,
possibilities they're seeing. Yeah.
yes. So again, for code scanning, you still go to advanced security again. And then there's now this bit of code scanning.
Okay.
So for the tools that are available for CodeQL analysis, you can set it as default or advanced. So if you choose default, it will automatically find the best configuration for your repository. So it will scroll through, and then it will determine which languages are being used in your repository automatically. And then you can also use like an auto advanced. So this one you just do more of customizing of your CodeQL configuration via a YAML file checked into the repository. So if you want to do a lot more like stopping or blocking a particular security vulnerability, if it only finds the critical security vulnerabilities or high security vulnerabilities. So you can define all that in the advanced features. But for now, all you'd have to do is just to choose like the defaults. And then you can see here, so it detected that I'm using all these languages. And so it's also defining which kind of runner that's going to use. So we're using the standard GitHub runner. And then the scan events as well. So these events will trigger a new scan. So if you are pushing or pulling creating a pull request to the main or protected branches, that one will spin up a new CodeQL scan to actually happen every time. That's why in the pull request, I think you saw all those alerts that were happening. That's because on every pull request, I'm also scanning for code security vulnerabilities.
Okay, so in an earlier picture, you said like shift left approach. So
Yes,
security is baked in this situation. At
yes,
least you're scanning. You still have some issues to fix, but at least the scanning is happening each time you push to your repository.
exactly. So you can see here as well. So remember like, earlier on as well, I mentioned like so many companies don't do regular security scans. So you
Exactly.
see here, you can be able to add and edit out how often do you want the scans to happen. So for me, I just do on a weekly schedule, and then it sends me a notification as well that these are all the scan results. So and then
Nice. Yeah,
yeah, and then all
that's
you
very
have to do now,
lovely.
yeah, all you have to do now is to enable the CodeQL. So what it does as well now is to create a workflow for you, and then now it will scan through let's see these actions. So you can see a CodeQL one, and then it goes through it, and then it finishes that GitHub action, and then it identifies which security issues are found within your code. And then after that, you can be able to see these security vulnerabilities within the code scanning issues. And you can see again, it's in order of severity. You can go in, and then it tells you again which line of code is actually vulnerable, and how to fix it. So you can show more about that security vulnerability, and then the fixed versions. Let's see if we'll see something else. Just to see if we can find one of these OWASP top 10 security vulnerabilities that we are very familiar with.
And one question. So,
Mhm.
if I have a solution and I just forgot to fix the things, does he cascade each time a new merge request, or is he bundling a few merge requests together if it's still the same
So
issue?
yeah, so it depends. Remember, if it's for dependencies, yes,
Hmm.
we have now that group pull request. So
Okay.
it fixes all that within one pull request. But for code scanning, it will give you that insight for each line.
Each time. Okay. Okay.
Yes,
It's
yes,
not bundling yet. Yeah. Okay.
it's yeah. Uh, so you can see here we have one for denial of service. It tells you how to actually fix that. Let's see if you can find another one.
And is it also in a sort of learning mode, like for example, if I have fixed something in a security code, will he apply that solution if he finds again that vulnerability, or is it just each time new code is scanned, he can do the same thing basically?
I think for that one, you can be able to define it within the advanced feature of CodeQL, because you've probably found there's this issue that keeps on recurring. So you can
Yeah.
define that within your YAML file so that
Okay.
it prevents that every so often. So you can be able to
Yeah.
define that in the advanced features.
To remove the false positives, for example, or a
Exactly.
known bug. Yeah. Okay. Cool.
Yeah, I very much encourage like to use the advanced features, because in most cases now you'll have also less noise because you've done the work. You've known that. So last time CodeQL found the security issue, and I probably found that it's not an actual security issue. So I'll probably have to say that it needs to be ignored. Um, but yes, so you can define that within the advanced YAML file.
Okay.
Yes. So the thing I like about this, if you've noticed something, for code scanning, we are using AI to fix your code scanning security issues. So we have Copilot Autofix for CodeQL. So what Copilot Autofix? So this one, we're using AI now to get how to fix the security vulnerabilities. So let's see. All you have to do is to generate a fix. So it's generating a fix suggestion for this server-side request forgery. Okay, anytime now. Yes, and then you can see now that it has given, so this is the original, and this is what it says will be able to fix that security vulnerability. As simple as that.
Nice. Nice.
Yes,
That's
it's
helping
amazing.
code even faster. Yeah.
It's amazing. Yeah. So it's that simple. So just go in and try all those features. Remember now for secret scanning, for dependencies, and as well as code scanning. There's something I had mentioned around dependencies, um, dependency graph. So you can be able to have that overall view of your, hey, let's take its time, of your dependencies from here. So you have your dependency graph.
Yeah.
So your dependency graph will show you the list of all your dependencies. So you remember, you've probably heard of an SBOM. So an SBOM is a software bill of material. So you can imagine in one project, you have probably like maybe 500 or so dependencies. And then for another project, you have like probably 800. So how do you keep track of all this? So you can keep track of all this using an SBOM. So you export this as an SBOM. So you have an inventory of all these dependencies for each of the softwares that you're using. So you can have a look like, okay, so of all these projects that we have, so which ones of them would be vulnerable? Because at least you're keeping track of all these dependencies that you're using. Okay,
And how does that look like? Can you show an SBOM in this example, maybe?
so in this case, it will just export as a TXT file.
Okay.
So I've just done that, and then it's in my downloads already. So you can see here it's in a JSON format. So the thing with the JSON format, JSON is machine readable. So you can be able to use this JSON file and then upload it now um, for further
Investigation.
uh, for your further investigation and further processing of the data as well, because at least it's machine readable format.
Okay. Cool.
Yes. You can also have your dependabot and your dependencies as well. So yes, I think that's a real crash course on the main aspects of GitHub Advanced Security.
Yeah, it looks amazing. You told so many things. Just asked a lot of questions in between, and just seeing it also in action. So yeah, it's amazing to see which possibilities are in a grasp if you are a developer in this case, and how you
Yes,
can basically secure it at forehand, or at least as far as it goes to the front end instead of just fixing things afterwards. So that makes encoding even easier and integrates security at the start. So loving this.
Yeah, yeah. Yeah, so that's for those who are using GitHub, but this capability is also available for those who are using like Azure DevOps. I think, Dinant, maybe you probably use Azure DevOps a lot.
I have some customers that didn't switch already to GitHub, and there was a long time that GitHub Advanced Security only was in GitHub until it was announced, I think, 2 years now for Azure DevOps. So if you have a short demo, we can maybe look to that, how
Yes,
that
yes,
looks
yes.
like.
Yeah, so this is how it actually looks like. So the same capabilities that we've looked at within GitHub. Remember, we were looking at dependencies, we were looking at code scanning, and we were looking at secrets as well. So the only difference here, so for secrets, it automatically scans once you've enabled advanced security. But for dependencies and code scanning, you have to define that within your pipeline. So if you have like your pipeline here, let me see which one was successful. Let's see this one. Let me edit that. So in this case, we have several capabilities. You've probably heard of DevOps security. So this is just a task for DevOps security. Let me see one of the other pipelines that we have. See this one. So for this particular pipeline, we've added tasks for CodeQL. So this one is what will look for code scanning security issues. And then for this case, since I know that I'm using specifically C#, I can define for it to be C# only, so that it doesn't take too much time as well to do the scanning.
Cool. Yeah,
And
that makes
also,
it more
uh,
precise indeed.
yes, and then we also added another task as well for dependency scanning. So this one as well is looking for the supply chain security vulnerabilities. And then this one analyzes the CodeQL findings, and then this one publishes the findings of the advanced security tools into what now you can be able to see within advanced security. And so GitHub Advanced Security for GitHub and both Azure DevOps, you can be able to see those security findings as well on Microsoft Defender for Cloud. So under DevOps security, you can be able to see all the security findings. Remember, this cuts across as well for different environments. So you probably have projects in Azure DevOps, on GitHub, or maybe on other cloud providers. So you can be able to link those ones to Microsoft Defender for Cloud. And then you can be able to scan as well for code findings, secret findings, infrastructure as code findings, dependency findings. So for infrastructure as code findings, so you can be able to use other extensions to find all the security vulnerabilities. But in our case, we have the DevOps security task, which has incorporated many of these scans, including infrastructure as code scanning tools like Terrascan as well, or Terraform. So it has incorporated all of that. So it will give you all insights around all of that here within your dashboard. It tells you the status if you've actually enabled advanced security. Okay, so on GitHub, it's called GitHub Advanced Security. So it tells you like for your Azure DevOps projects, if you've enabled it. So in this case, you can see most of mine are not enabled properly. And then it also tells me like for my GitHub repositories, if I've enabled GitHub Advanced Security. So in this case, I've not fully enabled GitHub Advanced Security. So meaning I might miss something. So what I always say, for us, you have to be lucky all the time. And for a hacker, they only have to be lucky only one time, because they can use that one time as well to infiltrate whatever that vector is, to infiltrate your whole organization. So we have to have security in depth as much as possible. So you need to be able to enable all these scans and have this visibility around all these features as much as possible.
Cool.
Yes.
Well, it looks great to see all those portals working together, also from an Azure DevOps
Yeah,
perspective. Uh, um,
exactly.
so I want to thank you for your time. We are almost hitting 1 hour, I see.
Yeah, let me quickly share some resources that the audience will find very useful.
Oh yeah, please.
Um, So by the way, apart from all those features, there's also a community of that's behind this. So this is the security community. So remember the advisory database community contributions. We have the private vulnerability reporting. So if you enable this, if someone finds a security vulnerability within your repository, they can be able to report that security vulnerability and probably get like a reward as well. And then we also have multi-repository variant analysis. So multi-repository variant analysis, it scans against, probably have like 2,000 repositories. So, and then you probably found a particular issue within one repository. So you can scan to see if this particular issue can be found across all those 2,000 repositories. And um, these are the resources that are quite handy. I personally have a certification for GitHub Advanced Security, and I encourage for us to go in and try this as well. So all you have to do is go to examinationregistration.github.com. You can learn more about GitHub Advanced Security learning path, and you can also have a lab environment as well for GitHub Advanced Security. So there's a lot to learn around this.
Cool. That was my last question, where to start, but you have already answered it in this beautiful lineup. Um, that's great.
I preempted it.
Yeah, yeah. Well, I must say I'm impressed how you can just explain it in just 1 hour. So we had a beautiful example how to press it up. But thank you very much for your time, also for your
Please,
nice demos.
let's
And
connect as well.
yeah, yeah, definitely. For people that want to connect, please use the information which is being displayed. And yeah, let's round it up for today. Are there maybe a last thought, like a best practice which you always say to your customers?
Yes. So I always say our first line of defense are actually developers. So for our customers, if you're working with any developers, you need to inculcate like a security first mindset for our developers. So you need to have regular trainings for them as well on secure coding. And it doesn't have to be complicated. It can be as simple as just what I've shown you in terms of how to use a solution like GitHub Advanced Security. And also, if you can find ways of incorporating these security scans where the developers are, even within their IDE, and train them on how to use those security tools and identify the security vulnerabilities within their IDE, that will be way better for your organizations as well. Yeah.
All right, that's a good tip. um, for everybody who is listening, thank you very much for your time. Hopefully, it's useful. Please leave a comment below, or if you want to come into contact, please let us know. And otherwise, I would say till next time, take care. Bye bye.
Bye.
Yes.